Okay, so please let me welcome Professor Ray Fair. Ray Fair is the John M. Mussel Professor of Economics at Yale University. Ray received his PhD from MIT in 1968. He spent several years at Princeton University before moving to Yale. Ray's research focuses on macroeconomic theory, econometrics, and macroeconometric modeling. He has published a large number of papers in top journals such as Econometrica, the Journal of Finance, the Journal of Political Economy, the American Economic Review, the Review of Economic Studies, the Review of Economic Statistics. His most well-known books on macroeconometric modeling include testing macroeconometric models and estimating how the macroeconomy works. He has also done work in the areas of finance, voting behavior, and aging in sports. His publication list counts about 160 entries. Ray maintains a macroeconometric model for US and 38 countries, data, software, and forecasts on his homepage, and that are also available for free downloading for use on a personal computer. He has made quarterly updates of his US macroeconometric model since 1983. He has made 4-year updates of his presidential vote share equation and made forecasts since 1980. He has estimated how fast people should slow down as they age if they remain in peak shape. Today's lecture is analysis of 9 US recession and 3 expansion. And Ray, the floor is yours.
Can I share screen?
Yes, please. Go ahead.
How do I do that?
You find on the bottom of the
share screen down here. Hang on.
Share screen, yes, and you can then choose which window you want to share.
Can you see that?
Yes.
Okay, yes. Great. Okay, yeah. I'm not going to do it yet. So I'm doing all the National Bureau of Recession since 1952, except for the one that Gianluca just talked about, which I am not doing, since we know that recession is quite different from any of the others. And so that's structural change that I'm not accounting for. So there's 9 NBR recessions since 52. I've also picked out 3 expansions, which I'm going to analyze. And I'm going to analyze using the model that Claudio mentioned, my US Macroeconometric Model. This is a model that's been around a long time. It's in the Coles Commission tradition. So the idea is that you use theory to pick the left-hand side and right-hand side macro variables, using theory on what should go on the right-hand side, estimate them by 2-stage least squares, quarterly data, starting in my case in 1954. So this is the structural econometric model goes back many decades. It's very different, for example, from the Hank model that Gianluca mentioned that he's worked on. I argue elsewhere that this methodology that I'm using, the Coles Commission approach, is a useful methodology. It's more, I argue, it's more empirical and can deal with more variables than the other approach. There's no calibration, it's all estimation. But I'm not going to discuss that today. I'm just going to assume that this is a model I'm using. It's documented on my website and in other papers if you want to, but this, I'm just going to take the model as given. The expectations are not rational. They're basically adaptive type expectations, which is true in this literature. I will say 3 things about the model that will be useful for the talk. One is that wealth effects are very important on household behavior. The wealth and household wealth consists of stock market, equity wealth, plus housing wealth. That's a variable. The wealth variable is in the consumption equations of the model and in the housing investment equation, with highly significant and economically significant results. So the wealth effects are huge in the sense that for the boom in the Clinton years, the stock market had a big positive effect on consumption and housing investment, and the falls in the stock market or vice versa. So that's one feature to keep in mind. Another feature regarding cost shocks, which is mostly relevant back in the 70s and 80s, is a cost shock. I'm going to use the price of imports, which is, you know, affected by the price of oil and other things. I'm going to take the price of imports as a cost shock variable. If that increases, if there's a cost shock there, it's contractionary in the model. In the model, wages follow prices. And so if you get a cost shock like that, the real wage falls. So real income falls, which is contractionary. In addition, real wealth falls because wealth doesn't rise equal to the cost shock. So real wealth falls, which is also contractionary. In addition, the Fed tightens up, and that's contractionary as well. So a cost shock like that, in my case, is contractionary. This is not true of other type models. So I want to just emphasize this is the characteristics that my work has. And finally, on the monetary policy, there's an estimated Fed rule, a Fed reaction function. Fed reaction functions go back long before Taylor rule. The first one I could find is in Dewald and Johnson in the 60s. Steve McNeese in the 70s worked on it. I added an estimated Fed rule, the one I'm using now, to my model in 1978. So there's about 40 years or 30 years between the first rule and Taylor's paper on the rule. So basically what I've got in the terms of monetary policy is a Taylor rule, an estimated Taylor rule, which is called now, but it goes back much further than John's introduction to his rule. And so the Fed policy is endogenous. Fed reacts to inflation by raising rates. It reacts to unemployment, high unemployment by lowering rates, et cetera. It's a standard Taylor type rule, which everyone realizes. So monetary policy is endogenous in the model. And so what do I do with the model? So I'm taking each one of these recessions, and I want to see how well the model predicts the recession. So I'm going to run a bunch of dynamic simulations starting in the first quarter of the recession or the expansion. Let me talk about recessions first, the expansions later. The first quarter of the recession, I run it out through the end of the recession and see how well the model predicts the fall in output and the rise in unemployment, if it does at all. There are two reasons that the model could be off. Two reasons you can get bad forecasts. One is that you may have used the wrong exogenous variables. Each of these models have exogenous variables, which is a key part of this paper, as we'll see. And I am going to condition on the actual values of the exogenous variables. So the predictions I'm making have no exogenous variable errors in them. So that means that if the prediction is still off, conditional on the exogenous variables, then it's got to be due to shocks to the stochastic, estimated stochastic equations. And it could be those shocks are true kind of random shocks, or they could be just misspecified model. The model's not good and it's got large residuals in it, so it doesn't predict very well in the recession, even though it's even though I'm using the actual values of the exogenous variables. The model's estimated through 2019, from 1954 through 2019. There's 246 quarterly observations. And I'm using all the data to try to get the best estimates of the model that I can, the most efficient estimates by using all the data. So this is not a forecasting exercise. If I say that a recession has been well explained, I don't mean that I could have forecasted that recession ahead of time. The model wouldn't have been estimated through 2019 at that time, and B, I wouldn't have known the actual values of the exogenous variables. So this is not meant to be a forecasting exercise. It's meant to explain the recessions. Can we explain the recessions based on the exogenous variables and the specification of the model? So that's the episode. There basically, we'll see there are about 2.5 episodes, which I'm not done well, model's not done well, but all the rest do quite well. So my theme is that I can explain and tell you why most of these recessions and expansions happen the way they did. So that's what I'm going to try to document as I go through. So that's the brief introduction. So what I'm going to do now is first show you what I'm trying to explain, the recessions and the expansions, show you the exogenous variables, which is a key thing. You may not agree that the variables I picked out should be treated as exogenous. So I'm going to give you those, and then I'll give you the results. So now I will share the screen again. So this is the first figure. This is the log of real per capita GDP from 54 to 2019. The solid lines are the period, the quarter before the recession started, and the dotted lines, I've done 3 for the expansions only. The dotted lines are the quarter before the expansion started. This is deviations from trend, log GDP deviations from trend, just so you can see the recessions and expansions better. The model is not estimated as in deviations from trend. This has nothing to do with the estimation of the model. It's just I did this because it's easier to see the recessions when it's deviations from trend. And you can see, the boom, you can see the recession in 57, 73, 80, et cetera. It's kind of obvious. The Clinton boom started in 95, went through 2000. So this is the Clinton boom. Then the recession that followed, the expansion that went up again, the housing boom in this period, the bad recession, what is called the Great Recession in 2008. By the way, I'm not a real fan of that Great Recession. This one here is just about as bad, if not as bad, so or in the 80s. So I think it's overblown that this is great, but I'll use that word because that's common. And then finally, this is an expansion here from 2009 third quarter on, even though it looks like it's down. Remember, this is deviations from trend. So the expansion from 2009 on is an expansion, but a sluggish expansion. So the question then is, can we explain that? But I'm still counting this as an expansion, even though it was moderate. So that's the basic data that I'm looking at. It may be easier to see the unemployment rate is a little better in showing perhaps the recessions and the expansions. You can see, for example, in the expansion after 2009, the unemployment rate did fall a lot. It's just that output didn't rise as fast as predicted. And of course, the unemployment went way up in the Great Recession as well as the other ones. So this is the unemployment rate. And then this is the Fed. Remember, the Fed's endogenous in the model, but this is what the actual Fed did, the actual data. And you can see this increase. This is the 3-month Treasury bill rate, which I'm using as the variable that the Fed controls. And that's went way up in during the Volcker period when he's trying to get the economy out of recession. But this is, again, I'm predicting this, not using the actual Fed behavior, but the predictions that we'll see are not too bad. So that's the data I'm interested in. Now I'm going to go flip down and discuss the exogenous variables next. And there's about 4 or 5 key variables I'm taking as exogenous. I'm arguing that all of these exogenous variables cannot be explained by standard structural macro equations. You can't take the left-hand side variable of these, or the change in these variables, and find any macro variables that can explain it. Fiscal policy is too erratic to be explained, etc. So this is fiscal policy. This is the log of real per capita government purchases of goods and services. This is the G part of C plus I plus G. Again, deviations from trend for the period. And you can see it fluctuates a lot. What I could flag right now is and it will be the explanation for the slow recovery, is you see government purchases went way down deviations from trend after 2009. So this was, as we'll see, the argument for why the recession was sluggish. It's the fault of fiscal policy. So this is purchases of goods and services. This is transfer payments, which the exogenous part of transfer payments, not unemployment benefits, which are endogenous in the model, but this is the exogenous part of transfer payments. This is both state and local, as well as federal. And you can see the big spike in the Great Recession, where the transfer payments went way up. The Republicans got in, and transfer payments went down in the expansion. This, I think, this blip here was, I think, due to something Nixon did to try to stimulate the economy to win the election. So this is not just a 1 quarter blip. So this is the second of the exogenous variables. Third is, and this is the key one, wealth. I said wealth is very important to the model, and it basically explains, as we'll see, a lot of the recessions since 1990. This includes both equity wealth. This is, again, deviations from trend, real household per capita household wealth, deviations from trend. It includes both equity wealth as well as housing wealth. And you can see, for a while, wealth didn't matter very much. And, you weren't going to get much out of that. But at least, of course, it went down in the 70s. But the really interesting part, to me at least, is starting about the time Clinton came in office, 1995, first quarter, the stock market in particular, more than the housing market, but just boomed, right, for 5 years. S&P, I think, was up 25% each year for 5 years in a row. So there's a huge wealth effect for Clinton. And then, of course, it burst and went back down. And then it went back up again after in 2000. This is both a stock market boom, but even more important in this part of it is a housing wealth boom. The housing wealth went, housing prices went way up until it burst in 2007, roughly. And then, of course, did it break? It really broke, because it went, this is wealth going, both household wealth, housing wealth, and equity wealth plummeted in the Great Recession. And we'll see that's basically the explanation I have for the recession. And then after that, it went back up again. And if I continued this, it would be off the charts above here. Because one thing that the pandemic did was to increase, and particularly now, is to increase the housing wealth and equity wealth. But that's beyond my analysis. So and I'm taking this as exogenous. I give my class every year when I'm doing this macro class, the goal of explaining the change in the log S&P 500 using any macro variable they can find that was known at the time. And they never find anything. You just cannot explain, I argue, the change in equity prices with any kind of stable macro variable. This, of course, is not surprising for finance. It's kind of, the change in price is more or less a random walk. So I'm taking this as unexplained and therefore known for my purposes. This is why it's not a prediction exercise, because I certainly can't predict this boom and bust in the stock market ahead of time. So it's not a prediction, it's just meant to be an explanation. This is a subset of the figure I just looked at. This is just the housing wealth. You can see housing wealth started going up in 95 and went up huge amount, and then, of course, completely collapsed in the Great Recession, and then, of course, is now back up again off the charts. So this is just a subset of what we've already seen. This is the price of imports as a function relative to basically GDP type deflator. And this, remember, is contractionary in the model. Went way up in the 70s. This is the Opec Oil Shock. Anchovies also went way up and had an effect in this period. So this is a huge shock. These are price of imports, but it's picking up these shocks that I'm interested in. And then another huge increase in the late 70s. And then Volcker went to work, and he was lucky as well, because not only did he contract the economy, but the price of imports started falling, and it's basically been falling ever since. And this explains a lot of, in the model, a lot of the fact that inflation has been moderate, more or less, since Volcker did his thing. So this is exogenous. I'm not trying to explain OPEC behavior, anchovy behavior, et cetera. And then finally, exports. Now this is endogenous in my multi-country model, because the US affects the German outputs, German economy somewhat, when then that affects German imports from the US, et cetera. So there is some endogeneity here, but the effect of the US on its exports is rather modest in the multi-country model. So for this purpose, as an approximation, and this is only an approximation, it's not for sure exogenous, I'm just taking this as exogenous, because I think the quantitative effects are fairly minor here, I would argue. Okay, so that's the exogenous variables. So I have one more thing I'm going to do before I get to the results. Is it's interesting to take and look at the stochastic equations, the estimated equations, and examine where are the large residuals. So these are the two-stage least squares residuals estimated over this period of 246 quarters. And I've taken the residuals in each of the equations, consumption of services, consumption of non-durables, consumption of durables, housing investment, plant and equipment investment is IKF, inventory investment, and imports. All of these are estimated equations. Imports, of course, subtract from GDP. Now, GDPR is real GDP, and it, of course, is determined by an identity in the model. There's no estimated equation. It's the sum of all of these things plus exogenous components. So I looked at all the residuals where the error in GDP, conditional given the residuals of the components, was greater than 1%. So this is where I can look to see where are the bad shocks. Again, it could be a random shock or something that the model doesn't account for. It could be some kind of misspecification of the model as well. And the biggest shock is in 1958 first quarter, minus 3.84, a huge shock to inventory investment and fairly large plant equipment investment. There was a shock in 78 second quarter, 2.44, big plus for inventory investment. Some of these are fluctuations for inventory investment, which are short run. But this, I'm going to come back to this table or refer back to this table a bit when I'm doing the analysis, because this tells me if the model doesn't do well in predicting a recession, are there any really bad shocks that I can focus on in this table to see why. Most of these, there are 27 of these periods that are greater than 1% in absolute value. Most of them are before 1990. So there haven't been, the model's been pretty good in this sense since 1990. Remember, this is all conditional on the exogenous variable values being known. These are the two-stage least squares estimated residuals, which are based on the actual right-hand side exogenous variables. Okay, so now let's see how I did. I'm not going to go through every recession in the interest of time. I'd like to have more time for questions if I could. So I may try to end less than 45 minutes. But let me give you a couple. This is table 2. So let's take the first recession. Began in 1957, fourth quarter. In the third quarter, 57, the GDP was 3.015, the unemployment rate was 4.2, and the interest rate that the Fed sets, the T-bill rate, 3.4. So the economy dropped by 3% in this period. That was a recession. The model didn't do that well. It wasn't booming, but it had only 0.8. The unemployment rate rose by 3.2 percentage points. The model said it would be flat. The Fed is estimated to have, the Fed contracted lowered the bill rate down to 1. The model, given the economy wasn't that bad, it didn't predict the Fed would do that. So this wasn't done that well, I would say. This is one of my failures. If you look back at the table I just mentioned, basically it's the unexplained demand shock in 1958 first quarter. So conditional on that bad shock. The model didn't explain it, and that then led to this recession basically not being explained. There are kind of no exogenous variables that I can call on to do that. So that's one mistake. The 1960 is a very mild recession. It dropped over this period minus 0.7 percentage points. The model predicted, again, not that great a growth, but not negative. Unemployment rate rose by 1/6. The model had it flat, et cetera. So this is kind of the same as the story I just mentioned. And here, if you go back to that table, there was an unexplained investment shock in the second quarter of 1960, which is one of the reasons that this was not done well. So another unexplained shock. So I'm starting out with the two bad ones. 69 was done well in the sense that it dropped in this period minus 0.7. The predicted output was drop was minus 0.1%. Unemployment rate rose 2.2. That was that was nailed. Fed behavior, which it cut the interest rate, and the models, the estimated Fed rule said it was going to connect to lower the interest rate, which it did. And why did the model do well? If you go back, and this is where I'm going to have to just you're going to have to, if you're really interested in this, you have to study it later because I can't flip back and forth that much. But the reason that this was done well is that there was a falling stock prices, wealth effect was somewhat negative, and there's a falling government purchases. So partly fiscal policy, partly wealth drop, which explains the 69 recession. The last one that I didn't do well, and this is only about half not doing well, was the 74 recession. The output dropped by 2.4. The model predicted a sluggish period, but not that bad. Same for the unemployment rate. The unemployment rate was predicted to rise by 2.2. It actually rose 4.1, and the Fed did more than predicted. So this did sort of, it did kind of got about half right, I would say. And why did it only get it half right, and why did it get the other half right? There was a unexplained demand shock in 1974 first quarter. So I'm going to go back to that table, and you can look at that. There was a shock that is unexplained, so that's why it didn't do that well. But in addition, why it did half well, you might say, is there was a high values of the price of imports. This is where the cost shock started to take place. OPEC's behavior, which is contractionary, and also the stock market fell some. So the part that it got right was due to import prices going up and stock prices going down. And then the rest of them are predicted, reasonably well, I would say. You can study that. I'm going to summarize all this at the end of the hour, but I'm only going to focus, in the interest of time, just on one more recession, which is the Great Recession. Now, many people think the Great Recession is something that's a puzzle to explain. You have to appeal to some kind of special financial frictions, etc. But that's not true in this story, in my story. Output fell by 3.9% in the recession. The model predicted it would fall 4.2. Unemployment rate rose 4. The model didn't quite get that right. It had it rising 2.8, but it was still rising from 5.3 to 8.1. The Fed lowered the interest rate, and the model nailed the Fed behavior in this case. And so why did that happen? And it's basically as you saw, I hope you can remember the graph, there was a very large fall in household wealth. Both stock prices fell and housing wealth fell in that case. So you had kind of a double whammy in that case, household wealth falling for two reasons, not just equity, but also housing prices. And in addition, exports fell some in this period. Those three, especially the wealth, can explain this recession. So I don't, to me, it doesn't seem like that the Great Recession is all that much of a puzzle. It's just in the aggregate, it's just a huge drop in wealth. And of course, a huge drop in wealth has a lot of financial implications, which have been very well analyzed in the literature, credit constraints and this and that, et cetera. But the big picture can be, the big macro picture is just if you take the actual values of household wealth that fell, it's the stock prices and housing wealth, you can explain it. Okay, so those are the recessions that I'm going to focus on. I'm just going to focus on, I guess I can mention the expansion under Clinton, because we've seen that the stock wealth was huge increase in that case. And this expansion started in 1996, first quarter, going through 2001. The total increase in output was 21.7% real GDP. The model predicted 19.2 at an annual rate. It was 4.7 under Clinton, and the model predicted 4.2. Unemployment rate fell by 1.6. The model predicted 2.2. The Fed raised the interest rate a little bit. The model got that right. So this is explained basically just by the wealth. So I'm as you can see, I'm relying a lot on wealth. This explains this boom. It explains the recession that I just mentioned, et cetera. So this is why I was focusing on wealth. Finally, the sluggishness, which doesn't have to do with wealth, is the sluggish response after the Great Recession from 2009 third quarter, where the recession was declared over, through, I'm stopping here at 2015, the total output rose 15% at an annual rate of 2.3. So, you know, that's not terrible. It is an expansion. It's just not as expansion as big as people predicted it might be, especially given the recession was so bad. But the model nailed that. Unemployment rate fell by 4.6. The model had 3.2, and the Fed kept interest rates zero. The model had the Fed not doing quite that. And why? This is again just simply, oh, this is not again. This is the fiscal policy. The two graphs I showed you after Republicans took over, purchases of goods and services, again, deviations from trend, fell, as did transfer payments, real G plus transfer payments. And so it's the sluggish fiscal policy, I argue, that leads to the sluggish, if you want to call it the sluggish response. So I have an explanation for most everything. Some wealth, some government spending, some price of imports, et cetera. So that's kind of the theme of the paper. What I have done, which I'm not going to take time to do because it's somewhat tedious, is I've taken each of these recessions in which I have an explanation. Some exogenous variables caused it. So I've then gone back in this table 4 and said, let's just say instead of the stock market falling or government falling or whatever the thing was, let's just assume it was normal. Exogenous variables were normal. And so how much would that have then, instead of whatever happened, so how much would that have increased GDP, lowered the unemployment rate, changed Fed behavior, et cetera? So this table takes the variables that I've already discovered seem to explain the recessions or expansions and see what would have happened had they been different, counterfactual. But I'll flag that as what I did, but I'm not going to focus on that. And there's not really any new news in the sense. It just gives you some quantitative things. The basic story doesn't change from what I've already said. So I'm going to table 5 is the same thing for expansions. What if the S&P had only been normal and housing prices had not risen, right? Just kind of normal wealth effects. How much, and the GDP would have been 1.1% lower over this period. By the end, 2.8% lower. So this is kind of reiterating what I've already said before. So I think I'm going to 1236. I think I'm going to see if we can get some dialogue more than listening to this. But I will summarize then what it is that the model does. Just remember, this is based on these dynamic simulations. Future error terms are 0. It's set to be 0, and using the actual values of the exogenous variables. So what I do, and I will go through these just to summarize. 1957 is unexplained demand shocks. I don't get that right. 60 was mild. There's an unexplained investment shock. Didn't get that right. 69 was mild. That's explained by stocks and SP as stock prices and government spending. 74 I got half right. The bad demand shock, but also the half right part is high values of the price of imports, OPEC type stuff, and falling stock market. 1980 was done really well, and this is the contractionary part of the price of imports. So, of course, the Fed, when the price of imports rose, the inflation, which price of imports has a big effect on inflation in the price equation, the Fed saw a lot of inflation and raised interest rates. So, the net effect of this exogenous, what I call the exogenous shock to price of imports, led to the recession. But of course, the Fed was contributing to that by endogenously, in my case, raising interest rates. And 1981 is the same story. Again, contractionary effects from the cost shock, plus exports fell in that case. 1990 was a very mild recession. The model did well, but there's not much, there's no real salient story here. So it was fine, but not very exciting. 1996, the expansion, the E stands for expansion. I've gone through that. It's a big wealth effect. The recession of 2001, which is fairly mild, was again falling wealth, mostly stock prices, not housing in that case, and exports falling somewhat. The 2003 expansion, this was a pretty big expansion, and this is again driven by wealth. Now both stock prices and in particular by housing wealth. This is the price of housing divided by some deflator. So as this goes up, housing wealth goes up. This is that plot I showed you earlier. So that's the expansion story. The Great Recession I've already discussed. Its wealth effects and exports. And I've also discussed the expansion story, which in this case is falling government spending and transfers. So going forward in terms of one last statement, going forward in terms of the pandemic story, the wealth effect is huge. If you ask what is it that the exogenous variables are doing now in my story, both housing wealth and stock market wealth are just off the charts. So in my story, this in the future is very expansive, very expansive. In addition, government spending and transfer payments have been pretty expansive, depending on as Luca said, $4 trillion or something over this, or maybe $2 trillion since the recession started. But part, of course, depends on how much of the infrastructure spending gets going. And monetary policy is predicted to still be, monetary policy still is very expansive. So all that leads the model, if I'm making a prediction to the future, to have huge growth in the future. But that's not this paper. That's going beyond that. So I think I will stop here and take questions. Maybe, Claudio, maybe it'd be best if you read the questions to me, and then I can answer them. Then people will know for sure what the question says. And then I'll answer it after you've read it.
Yes, yes, indeed. We'll just to stop recording.